Okay, so we're considering a couple of different functions and wanting to know their derivatives. And let's call the first one f of p, and it'll be 3 over p. Let's go down a little bit. There we are. F of p is 3 over p. And I would like to find f prime of p. I'd like to find the derivative. What are we doing with that light? Is it going to focus less? Yes. Let's try that for a minute. All right. Well then, I know that f prime of p, that's still not doing very well. It's specifically defined to be this limit. And this is the limit that it's defined to be. F prime of p is equal to the limit as h approaches 0 of f of p plus h minus f of p, all divided by h. It's a difference in outputs divided by a difference in input. Right? This h is something that is increasingly small, and so I added it to the p that I'm plugging in to get a new point, and here's the output of the new point, and here's my old input, just plain old p. So here's the difference of those. And then I'm dividing by that difference in inputs, which I defined to be h. That's why I added it up here. And so I just have to figure out what to plug into the holes here so that I can evaluate this limit. Okay. So f of p plus h is me plugging in a p plus h everywhere where there used to be a p. So this is the limit as h approaches 0 of 3 over p plus h. There's f of p plus h. It used to be 3 over p. Now it's 3 over p plus h, the quantity. And f of p was just given to me, so I can plug that into the hole. And then I'm all dividing by h. So this is what that limit looks like. Now filled with all of these algebraic symbols instead of the functional notation, which if I don't know what f is confusing. But this is still maybe not ideal, right? It's got fractions inside of fractions, which I am not as big of a fan of as I could be. So I'd like to simplify this expression, and hopefully in simplifying it, I will find that there is some factor of h in the top so that the h in the denominator will get canceled. Okay? Remember, my problem here is that if I plug 0 in, I get 0 over 0. I've got this 0 in the denominator, and I desperately want to get rid of this h. So I'm hopefully in simplifying this expression, by trying to get rid of this situation where I've got fractions and fractions, a factor of h will kind of resolve itself in the numerator, and I'll be able to cancel it out. There is a kind of standard procedure that we might use in order to get rid of these compound fractions, these fractions inside of fractions. How might I get rid of it? How might I try to simplify this so that I don't have fractions and fractions? So if you have something in a denominator, right, we're dividing by it, right? That's the gist. So if I want to undo that process, if I want to kind of get rid of what's underneath, what can I do? What about a common denominator?
So you have to make both of them times the other one by h.
And so one of them definitely would need they're going to need some factors. Right? I like this idea, right? The common denominator is definitely going to help me out. And I've got a couple of options. One would be to just take these two different fractions and try to mush them together into a single fraction so that I wasn't adding a bunch of stuff. That is equivalent to just trying to kind of eliminate their denominators to begin with, and that's generally algebraically a little bit cleaner. Right? So that's what I'm going to do. I don't like this p, so I'm going to multiply by p. Do we see the advantage of multiplying by p? Now, if this p were to distribute through, right, when it hits this 3 over p, I'll have times p divided by p, and they'll cancel. But when it gets over to the 3 over p plus h, it won't cancel anything over here. So I'm also going to have to multiply by p plus h, so that when it distributes through, it'll cancel this p plus h. But you can't just run around multiplying fractions by whatever you want. It changes that expression, right? It's no longer the same expression that it used to be, right? Here's the expression that it is, and now once I did this, I've changed it. So I'm going to both multiply and divide by p and p plus h. That way what I'm really doing is multiplying by 1, right? I've both multiplied and divided by the same expression, so that should just be the same as multiplying by 1. This is our big algebraic trick for making things look different, right? You either multiply by 1 or you add 0. And it's like you need to add the right 0 or multiply by the right 1. And then the algebra might work out okay. Right? So this seems like it'll do pretty well. Once this distributes in, this p will go. Once this distributes in, this p plus h will go. And I've added some extra stuff into the denominator, but maybe that'll be okay. Equals the limit as h approaches 0. So what's the fallout here? When these expressions, when this product gets distributed in, the p plus h's will cancel, but the p won't. So I'm going to have 3 times p. And when they distribute into this second term, the p's will cancel, but that p plus h won't. So minus 3 times the quantity p plus h. And in the denominator, I've got an h, and I've got a p, and I've got a p plus h. And I'm okay with that, right? Extra terms down there are fine. I'm going to leave them all factored out also, because remember, I'm trying to get rid of this h factor. Having these other factors down here isn't bothering me a lot because I know that h is shrinking to nothing. And so this p is going to be some p, and p plus h is going to look an awfully lot like p. So they're not putting extra zeros into the denominator, so I'm pretty okay. I'll continue to simplify the numerator, though. I'll distribute this 3. So that's 3p minus 3p minus 3h, all divided by h, p plus h, limit as h goes to 0. I'm getting tired of writing that. Hopefully I can evaluate this soon. And I can see that I have a 3p minus 3p, which is fantastic. That's just 0. Slide up here to the top. So this is the limit as h approaches 0 of negative 3h divided by h, p plus h. So that numerator simplified down quite a lot. I had to add a little bit of extra stuff into the denominator, but it's not stuff that's horrible. And now once it's simplified, I do have that factor of h, right? Exactly what I need in order to evaluate this limit. Because this h is being multiplied by the entire numerator, and this h is being multiplied by the entire denominator. So I'm both multiplying and dividing by h, which should be 1. And now I got rid of that pesky h in the bottom that was making me divide by 0. So now what happens if I just try to evaluate it? If h is 0, this looks like negative 3 divided by p times p plus 0. That's negative 3 divided by p squared. And that should be f prime of p. There it is. F prime of p is negative 3 divided by p squared. Any questions about that? All right. The other type of function that we might see here, with which we are unfamiliar as of yet, is maybe g of x equals the square root of x. Called the last one f, so we'll call this one g. And again, the derivative is defined by that same limit. The limit as h approaches 0, and you plug x plus h in, and then you subtract the original function, and you divide by h. Okay. This is called the difference quotient, and this is how the derivative is defined. This is the strict definition of the derivative. G prime is equal to this limit. We just have to figure out how to evaluate this limit so that we get rid of the h's, right? Especially that h in the denominator. Any ideas? Is there something that I can do to the numerator to make it more friendly for me?
Multiply it by of itself.
Almost itself.
So is it's reciprocal.
It's called its conjugate.
Conjugate. Okay.
All right, so I'm going to multiply by root x plus h plus root x. Right? So that it's almost exactly the same. The only difference is that this is minus and this is plus. The advantage there is that I'm going to wind up with a difference of squares. This is the process that I can go through that's going to wind up squaring each of those terms, which will get rid of these square roots, and hopefully algebra will ensue. But again, I can't just run around multiplying only the numerator. I also have to divide by that same expression. So there it is in the denominator also. So great things are going to happen in the numerator. I will have the limit as h approaches 0 of x plus h minus x. The denominator looks messier for all of that. But hopefully it'll clean up, maybe I'll get rid of that h, and then the rest of it down there doesn't look like it's going to be 0, so I'll be okay with whatever it is. And once again, the algebra helps me out. X minus x is 0. We have the limit as h approaches 0 of h divided by h times the square root of x plus h plus the square root of x. And I have these common h factors, which divide out to get 1. And I just have the limit as h approaches 0 of 1 divided by the square root of x plus h plus the square root of x. And because I don't have that factor of h in the denominator anymore, I can just run through here and evaluate it. Right? I got rid of that division by 0, so now I'm just going to try to plug it in. Seems like continuous enough of a function. So that's 1 divided by root x plus root x, which is 1 divided by 2 root x. So that's f prime, or g prime. We're talking about g's. G prime of x is 1 divided by 2 root x.
Can you put the other one back on?
Yeah, absolutely.